This things like composite materials, polymers, elastomers, ceramics, and glasses has started in 10,000 BC. In the 10,000 BC, it's like in the ceramics and glass, it starts with the stone slate, pottery, glass, cement. I think all things you already know. And even in the composite, it starts with straw brick, then paper. I as mentioned already, paper. Nowadays, we are start to using glass fiber reinforced polymers, carbon fiber reinforced polymers, Kevlar reinforced polymers, and metal matrix composites, ceramics composites. And in polymers and elastomers, it starts with wood and skins and fibers, glues, rubber, and then it starts with PE like polypropylene, polyethylene, polystyrene, polyesters, high modulus polymers. Nowadays, we are working on high modulus for polymers and high temperature polymers for different kind of applications. Then, in terms of metals, it's in the Stone Age. It starts with the gold, copper, bronze, then iron, cast iron, steels. It depends on the application and time to time based on the applications only. Like different kind of application, different kind of materials evaluation happened. See, I said no. In the ancient days, even in the 10,000 BC, they're constructing the homes by using straw bricks. Straw bricks also made by mud and straw. It means that also is a very oldest composite material which we are already used in the 10,000 BC. Are the composite materials are new? Now we can conclude it's not new. The composite word itself, it's not a new. But using the high strength of fibers to stiffness and strengthen the cheap matrix material is probably older than the wheel. Now we are using different kind of stiffed and strengthened fibers to improve the composite material for different applications. Almost all natural materials which must be valued, wood, bone, muscles, or composites. I have already mentioned these things. And another thing, the composite industry, that is from past 30 years, it's growing rapidly in the area of fiber composites. Even me and your professor Femi are all are working on fiber reinforced composite because based on the applications. And now we will go to different kind of applications. As you're all bachelor students, I don't want to take and give more theory for you. More than that, you just understand the real application. That will be better for understanding the theory as well of the real nature. For example, I said already, straw bricks, concrete. Generally, we are using for making houses or homes or buildings, such things. Our human body itself having so many kind of composite materials, and the tires, most of the transportation components are made by composite material, and plywood for interior, exterior, and everything that also composite material, and even in the sports goods. And we now will move to evaluation of materials, like use of modern polymer composites. During World War II, the military applications, most of the military applications that were related to the aircraft made by glass fiber reinforced composites. In the glass fiber reinforced composite, it is belong to the fiber reinforced composites. Otherwise, it is belong to the group of polymer composite. In the glass fiber reinforced composite, glass fiber is the reinforced material and polymer is the matrix phase, which we combine glass fiber with the polymer, then it will be a composite, polymer composite. And the first application of wood composite material or wood composite laminate, that means wood is the reinforcement material and polymer is the matrix material that They are used in the heavy light and mosquito fighter bomber of British Royal Air Force in during World War II. That is the first time application of wood composite laminates. And then they start to use in different kind of flights for attack on Pearl Harbor by Japanese. In the World War, during the World War, the most of the aircraft parts are made by polymer composite. Even nowadays, also most of the aircraft parts are made by polymer composite materials. And composite in ancient times, I discussed this things already, like mud wall reinforcement with bamboo shoots. I think we can see nowadays also in some museums, even in Indonesia, India, and Thailand. We know that most of the our ancient homes are made by mud and bamboos and bricks with straw. That Israelites have started to use bricks reinforced with straw and bitumen embedded with the papyrus for boards and powerful bows using wood animal tendons, silk, composite swords using laminate steel and iron, and growth of composite materials. In 1909 to 1947, the US and UK has utilized thermoset resins, phenolics, polyesters, epoxy for making aircraft and automotive applications. And 1940s, that for World War II growth, then they are start to use this kind of composite materials for structural application. Then 1940 same Spitfire composite aircraft made by natural fiber with polymer composite, like they made by UK, that is with flax fiber and phenolic. Then 1942, they start to utilize glass fiber with polyester by USA. And 1947, commercial glass fiber based CSM introduced. 1950s, then fiber reinforced composites became a popular technology for boat hulls, car bodies, truck body, tanks, helmets, chemical industry. That means after 1950, the fiber reinforced composites are very popular and start utilizing the many applications because, as I said, this is stronger and lighter. And then thermoplastics are start to utilize in the many modern applications, like because of its a thermoplastics are low strength, low thermal resistance, and high processing cost. And the fibers for structural applications, that many like fibers are available for structural applications like glass fibers, boron fibers, carbon fibers, aramid fibers, or Kevlar fibers. This kind of fibers is for reinforcement interface for composite material in polymer composites. And naturally occurring composite. I said no, wood, bone, and granite are the very natural available composite materials. And I will move to next one and try to understand these are all not composites. One thing, plastics. Plastics are not composite materials. But composite plastics are one of the thermoplastics polymers. And alloys are also not composite materials. Even metals are also not composite materials. But if we blend plastic with some reinforcement, then it will be a composite. And same like alloys with something matrix material, then it will be composite. And again, metals with some matrix material, then it will be a composite material. That means these are all matrix phases, reinforcement phases. We need matrix material to combine to make composite materials. What are the some forms of composite materials? General, I said no. Wood, because of cellulose fiber in lignin, plywood, concrete, fiberglass, carbon reinforced polymers, metal matrix composites, ceramics matrix composite, and Damascus. Why would you want composites? I generally now I discuss about the definition, then I move to the application and the history of composite material. Now, why we need composite material? And I have given already small things, small hint. Because composite materials are very strong and stiff and yet very light in weight. So ratios of strength to weight and stiffness to weight are several times greater than the metals. For an example, steels and aluminum, if you compare, the composite materials like polymer composites or ceramic composites or metal matrix composites are much stronger and stiffer than these individual metals. And fatigue properties are generally better than for common engineering metals. And toughness is also often greater. And composite can be designed that do not corrode like steel. That is another one. The most of the composite materials are corrosion resistance. This is one more advantage when compared to metals. And then possible to achieve combination of properties not attained with individual things like metals, ceramics, or polymers. If you take only metals, ceramics, and polymers, we will not get this much of performance like composites. Why composite is necessary? What are the desired properties? Because why composite material? Because of this desired property of composite materials. What are the desired property of composite material? I said no. Strength, stiffness, toughness, corrosion resistance, wear resistance, lightweight, that is reduced weight, fatigue life, thermal and electrical insulation and conductivity, acoustic insulation, energy dissipation, attractiveness and cost, and Tyler properties, and feasible for using in many applications. Now, again, I would like to give small repeat explanation, like reinforcement is discontinuous, stronger, and order, but matrix is continuous. And what are the functions of a reinforcement? Now, we know that reinforcement and matrix material will give the better performance for composite material. Then what are the functions of a reinforcement material? Well, first one is it will contribute desired property to the composite. And among reinforcement and matrix, which one is the load carrying material? Is load carrying material is reinforcement. Sorry, load carrying material is the reinforcement material, and it will transfer the strength to matrix, because matrix is not having this much strength like reinforcement, but reinforcement material will give the strength to matrix material, and it will carry the load of complete composite. And what are the functions of matrix? As we discussed already, it will hold reinforcement together. Either reinforcement material is fibers or metals or ceramics or fillers or particulate, anything, it will hold with matrix and protect the fibers from environment and protect the fibers from abrasion. That is the wear resistance. Helps to maintain the distribution of fibers inside the composite and distributes the loads evenly between fibers to fibers, and enhances some of the properties of resulting material and structural component that fiber is not allowed to import. These are the main properties of matrix which are giving to the composite material. And matrix material will give better finish for the final product. The fiber will not give the finishing structure. Only matrix material will give the final structure. And now we will move to classification of composite materials. Usually, we have to give explanation from definition, classification like that, but I have changed a little bit. I go to the history, and I would like to talk about the natural composites, what naturally available, those things. Then now we will move to classification of composite materials. Usually, we will divide the composite into two groups based on the phases. One is matrix phase and reinforcement phase. And again, in the matrix phase, we will divide into five groups. No, sorry. Matrix phase is three groups, like polymer matrix, metal matrix, ceramic matrix. And again, in the reinforcement, we will divide it into four parts: viscous reinforced, particulate reinforced, fiber reinforced, and structural composites. Structural reinforcement composites. But important classifications of composite materials are based on matrix materials, like polymer matrix material, metal matrix material, ceramics matrix material. Those are the important category of composite materials. Again, in polymer composites, we will divide into two groups, that is thermoplastics and thermosets. It means based on the polymers. One is thermoplastic and thermosets, and even based on the metal matrix, different types of metal matrix and ceramics matrix. But metal matrix we will not divide again, we will not divide again, but polymer matrix we will divide again as a two parts: thermosets and thermoplastics. And again, based on the reinforcement, as I said, no, it's on viscous, based on the structure actually, based on the reinforcement structure. If it is in the form of particle, then particle reinforced. If it is in the form of fiber, then it is fiber reinforced. If it is in the form of whisker, then it is whisker reinforced. If it is in the structure like laminate or sandwich, then it is structural reinforced composite. And in the polymers, we will use it like particle reinforced polymer matrix composite, fiber reinforced polymer reinforced composites. Such things will come. Okay. As I said already, the classification of composite material. And I discussed already about these things just for the glance and the repetitions. For all our you're all bachelor student, just to glance these things. Like I said no before, it is made by two things like matrix and reinforcement, and the properties for matrix phase, why we need matrix phase, why we need reinforcement phase. Okay. Okay. Now we will move to this one. Classification of composite, as I said, based on the reinforcement material. The main thing is particulate composites and fiber composite and structural composites. See, here this is particulate composite. It means the material which we use it for this composite, it's in the form of particle. Then here, fiber composite. In this, the the reinforcement material, that is fiber, in the form of fibers, thread-like structure. And here it is in the laminate. Laminate means matte. The fibers or the reinforcement material in the form of matte or fabric. That is called laminate composite. And flake also, based on the size. That is called flake. And filled composite. In filled composite, we can fill fiber, particulate, flake. That is generally we will call filled composite. And again, we can call it as long fiber. Based on the fiber composite, we can divide again as a long fiber composite, short fiber composite, and even the particulate composite also we can make it like a micro particle, like a nanoparticle based composites, micro particle based composite. Again, like that. And I said already, the particular reinforced composites with a random orientation of particles, and composite with preferred orientation composite. Again, we can divide based on the particle orientations, like the particle in the which angle, like a 0-degree angle or 45-degree angle or 60-degree angle. It is like that. And what are the most particles, reinforced particle, like composites? It's like concrete. In the cement also, it's a particle reinforced composite. Or otherwise, in the terms of metals, if you use aluminium or aluminium oxide, and like metallic or non-metallic oxides, that is also particular reinforced composites. And even fibers in the form of fillers or particles that also belong to particle reinforced composites. Example, I said no, like particle reinforced composites. Best example, paint, ink. Our ink also particle reinforced composite. Paint, porosine, electrical contacts, heat sinks, brake pads, electromagnetic sheets. These are all particulate reinforced composites. And even permanent magnets, correction fluids, cemented carbide, wear resistant aluminum. So many things all belong to particle reinforced composite based on the application and size of the particle which we are using in the composites. And next, fiber reinforced composites. Like I'm working on natural fiber composites, even I'm working on synthetic fiber composites like your professor Femi. Based on even fibers, we will divide into two categories, long fiber and short fiber. In again, we can divide into continuous and allied. This is continuous and halide fiber reinforced composites. Then this one is discontinuous and allied. Discontinuous and allied. The fibers here, fibers are is in continuous and allied. Here, the fibers is in discontinuous but allied, and this one is discontinuous and randomly oriented. So, based on the application, we have to choose which type of composite is suitable and which classification is suitable for which type of applications. Like even we will use short fibers, long fibers, and we have to think about if you use short fiber, what is the property? If you use long fiber, what is the property which we get? And in the long fiber, unidirectional fibers, bidirectional fibers, we will call O1 mats. And the structural composites are very clear. There is two only, laminate composites and sandwich structures. See here, this is laminated reinforced composites. Here in the fibers or in aligned directions like 0 degree or 90 degree or 45 degree. This is our laminated stacking sequence. Otherwise, we can call laminated reinforced composites. And see here, these are all reinforcement material, and we will combine this by matrix materials. And even based on the orientation also, we can increase the stiffness and strength of the composite. And even based on the orientation also, like a strength and stiffness will be based on the orientation of the fibers. And then this one is a sandwich composites. Even honeycombs, we can use it as a reinforcement material in the composite. That is, we can call it as structural sandwich composites. I don't want to explain more on this one. This is really belong to the masters and PhD candidates. Like why we need like sandwich structures. Same thing. We will be competing with the steels and like steels and aluminum alloys. Compared to this, metals and materials, it will give high stiffness and strength to the structure. That is the reason behind why we using sandwich structures in many applications. And we can use phenolics, epoxy as a polyurethanes, like polymers, different kind of polymers for as a reinforced matrix materials. Now we will go to the main classification like metal matrix composites, ceramics matrix composites, polymer matrix composites. See, for bachelor level, you understand this metal matrix composite means here matrix material is a metal. And this one is ceramics matrix composite. Here, the matrix material is ceramics. And here, the polymer matrix composite, here matrix material is polymers. That's easy to understand. So, in metal matrix composite, what are the matrix which we are using? Like a different kind of metals like aluminum, magnesium, iron, cobalt, copper. This kind of different metals are using in the metal matrix composites. Okay. Same thing. And just telling you, like applications, most of the metal matrix applications in automobile and aerospace industries. And in the ceramics matrix composite, as I mentioned, ceramics usually in the form of particle and it's a discontinuous phase. And for an example, different kind of ceramics matrix, ceramics or like tungsten carbide, magnesium carbide, silicon carbide, different kind of ceramics which we are using as a matrix material in the ceramics matrix composites. Usually we will use it for home appliances. When high temperature application comes, we will use ceramics matrix composites. Even our bathtub sinks are made by like ceramics matrix composites. But my class is on polymer matrix composites, right? So in the polymer matrix composite, I said no, matrix material is polymers. And we know that polymers are divided into two categories, that is thermoset and thermoplastic. Usually thermosets are polyester, epoxy. These are the very familiar thermoset polymers like polyester and epoxy. And thermoplastic like PVC, like polyvinyl chloride, nylon, polystyrene, and polyethylene. These kind are the popular thermoplastics. And even rubber also polymer, elastone. I will move this one. Why? And moreover, compared to metal matrix composite and ceramics matrix composite, polymer matrix composites are very popular. Why very popular? Due to their low cost and simple fabrication methods, and also lightweight materials. Polymer matrix composites are lightweight materials compared to ceramics matrix material and metal matrix materials. And usually the reinforcement materials in polymer matrix composites are fibers, either synthetic fibers or natural fibers or hybrid fibers. That means even I said no, we can divide it into continuous, long fiber, short fiber, or continuous, or discontinuous, or even based on the orientation of fiber, we can classify it again on polymer matrix composites. What are the desired properties of polymer matrix composite? Why this much popular in the field, or why this much popular for many applications? Because first thing is high strength, high tensile strength of polymer composites. And next is high stiffness. And next, high fracture toughness. And next is good abrasion resistance and good corrosion resistance. And compared to metals and ceramics, polymers are cheaper. So if we prepare application by using polymer matrix composite, those applications are having high strength, high stiffness, high fracture toughness, good abrasion resistance, good corrosion resistance, and low cost. And according to reinforcement material, I said many types of fibers which we used as a reinforcement material, either natural fiber or synthetic fiber. Most commonly used synthetic fibers are e-glass fibers, carbon fibers, and Kevlar fibers or aramid fibers. Natural fibers, so many kind of natural fibers are used in many applications like sisal, jute, bamboo, banana fibers. So, like most commonly available natural fibers. See, this is the, I said the man-made fibers is synthetic fibers. Synthetic fibers is nothing but is man-made fibers. Even polymer itself is a man-made fiber. Fiberglass, polyesters. These are the some of the examples for synthetic fibers. Most commonly used synthetic fibers are e-glass, carbon, and Kevlar. And even for natural fibers, again we can divide into different groups. But most commonly available natural fibers are jute, sisal, wool, cotton. We can use this natural or synthetic fiber as a reinforcement material for polymer matrix composites. Rather than the metal matrix composite and ceramics matrix composite and polymer composites, we have hybrid composites. Nowadays, whatever we are using composites or hybrid composites based on the application. Which means how it is hybrid. See, if it is fiber reinforced composite or polymer composite, in the reinforcement, they will use more than one different fibers. Like sometimes they will use carbon with e-glass, e-glass with like Kevlar with the synthetic material, even combination of synthetic with the natural. It means if you combine different chemical property material and different physical property material, then it is a hybrid composites. Why we need hybrid composites? Again, the question. Because if you hybridized, then it will increase the stiffness and more strength also. Again, we can balance the density of the reinforcement material. Sometimes some materials are expensive, but if you compare with the metal matrix and ceramics matrix, it is cheap. And sometimes we can balance the expensive materials in hybridization. Like say here, I have given the example, glass fiber in glass and carbon fiber reinforced polymer matrix composites. We have means in this composite, the reinforcement materials are two. One is glass fiber and carbon fiber. Why carbon fiber? It will give more, it is stronger than the and stiffer than the glass, but it is expensive than the glass fiber. But glass fiber is inexpensive than the carbon fiber, but compared to stiffness and strength, it is lesser than the carbon fiber. But if you mix this combination, then it will give stronger and tougher. And we can balance the cost also, and we will get high impact resistance. See, continuous fiber, discontinuous fibers, or viscous and particles, fiber brand. As you're all mechanical student, now we will discuss about mechanical behavior of composite materials. I said already, traditionally the composite materials are homogeneous, but if we mix with another one, it will become heterogeneous. And composite materials are combined with two distinct properties to increase strength and stiffness. And in terms of mechanical, we can say it will increase, like it will lightweight, like density, internal structure, tensile strength, modulus, elongation, impact. These are the considerations on mechanical behavior of composite materials. And advantages of composite materials. As I said, composites or engineering materials. We can engineer them specially to meet our needs on the case-to-case basis based on the application. In general, the following properties can be improved by using composite material. There is strength, modulus, weight, electrical conductivity, thermal conductivity, fatigue, behavior at extreme temperature, acoustic insulations, vibration damping, aesthetics, resistance of the to wear, resistant to corrosion. These terms, I hope you understand already why we are using composite. What are the advantage of composites? And the limitation is, first thing, it's anisotropic and non-homogeneous. No need to think about the limitation of composites. We should always think about the advantages of composite materials. And generally, composite materials are costly, and sometimes it is difficult to fabricate and sensitive to temperature. And some polymer composites are master effects. So those are the limitations for composite materials. And what are the applications of composite material? Already I discussed, like there is no field of engineering without the footprint of composite material in some form, which means now if you consider any like field of engineering, Definitely one or another way the composite are there in many applications. Like composite material is in some way. And the application of composite materials can be broadly classified into, and moreover, composite is a interdisciplinary subject. Even the composite will involve mechanical, material, production, like even the computer science people also will use composite materials. Everyone, biotechnology, medical, engineering, everyone will use composite materials. So it is a very interdisciplinary subject. And the application of composites will broadly classified into aerospace application, road and rail transport application. That is a transportation application. I've showed occurred water vehicles, building and other civil structures, chemical industries, electrical and electronics and communication applications. That means even electrical electronics, those engineers will also involve in the composite materials, mechanical systems and machine elements, consumer durable products and sports application, biomedical application. We will discuss like coming in upcoming slides. Like what are the composite which we are using in automotive and automobile applications? Like chassis components, body components, like interior and exterior component of automotives made by composite materials, engine components, like major these three parts are made by composites in automotive and automobile applications. And why we are using? Because of, as I said already, high specific strength, low wear and tear, attractive styling. It will give better like finishing, high resistance to damage, high resistance to corrosion, high thermal insulation and sound retaining properties, easy repairing and maintenance, free structural elements. And what are the materials used in the automotive application? What are the different kinds of composite which are we using in the automobile application? I said no. Most of the automotive and aerospace application which are using glass fiber reinforced composite or carbon fiber reinforced composites. Like E-glass fiber reinforced composite sheet molding components. Composites are used in the hold and door panels of the automotive, radiator supports, bumper beams, roof frames, door frames, engine wall covers, timing chain covers, oil pans, and even E-glass are used in the multi-leaf steel springs. And glass reinforced composites are used in the like bus bodies, roof panels of the bodies, engine bonnet, tailgates, mud wings, bumper bars, window frames. It means most of the parts are made by composite material. That too from the polymer composites, fiber reinforced composites. Even petrol tanker, chemical tankers, and these milk tankers are made by composite materials. And in the railway, it is like wash basins, battery box, seat, backrest, bathroom cubicles, window frames, guides, loughs, undercarriage water tank, vacuum reservoirs. You can see, if you see in your room itself, you can get many kind of composite materials. Even our laptop also composite material, like our laptop made by like polymer reinforced composites. And processing techniques, most famous processing technique for automotive and automobile application is hand layer technique and compression molding technique. These two are the very like very simple and most popular processing techniques for making automotive and automobile applications. See, this BMW M6 car, the most of the interior and interior and outer panels, especially body panels, are made by carbon reinforced polymers. And this one is, and even the roof also made by carbon reinforced composites. See, this one is race car made of composite. And now we can understand carbon fiber reinforced composite. They will use it for high cost cars, or if the car or automobile is very strong means most of the times you can understand that is made by carbon reinforced composites. And that's why if it is made by e-glass fiber reinforced composite, then the cost is less. If they are made by carbon fiber reinforced composite means the cost is more. If they're made by Kevlar means again cost will be more. See here, in the Formula One race car, chassis, interior, and suspension components are made by carbon reinforced polymer composites. And in wagons, and even in the fronts of power units, door seats, these are the common applications of composites in automobile and automotive applications. And next, in aircraft and military applications, what are the in the history itself, in the World War itself, the people start to use polymer composites or fiber reinforced composites in aircraft. And after that, like scientists all start to use it in rockets, missiles, spacecrafts. And moreover, most commonly airspace vehicles, why they are using composites in aerospace vehicles? Because of lightweight, one thing, then eye strength, eye stiffness. And if lightweight and eye stiffness are very, if you consider lightweight, then fuel consumption is less. It will decrease the fuel consumption because of the lightweight material. And yes, then primary advantage of composite material can be tied to meet specific requirement and step. I said no, based on the requirement and application, we can prepare the composite materials. And if you decrease the weight reduction, then the speed will increase. That's why in Formula cars, why they're using instead of metals, they will use fiber reinforced composites. Fiber reinforced composites are lightweight and stronger than the metal matrix. That's why they will use it for Formula cars. Like it will increase the speed and it will decrease the fuel consumption. See this fighter aircraft, like wing, fuselage, and ambulance is made by carbon fiber reinforced epoxy composite. I said no, thermoset. Epoxy is the most popular thermoset polymer in the world. And the epoxy will be used for aircraft and aerospace and automobile applications, along with different synthetic fibers or natural fiber. And see this one, AV-82B fighter craft made by, see in this aircraft, 25% nearly weight of carbon fiber polymers are there. Which means in the 100%, 25% of materials are made by carbon fiber reinforced polymers. And next, this one, it's like fighter aircraft. The outer skin of B2 and outer sheath aircraft are almost made by carbon reinforced. That means I said no, carbon reinforced polymer is very famous for using in the aircraft and military applications. Airbus A310, A320, and this is Boeing 770 is made by carbon reinforced composites, and about 50% is made by aluminum alloys. 10% of Boeing. And here in the Boeing 787 Dreamliner, the 50% weight as reduction by using carbon fiber reinforced polymers instead of using aluminum. They used carbon fiber reinforced polymers. See, this is like some older aircrafts. Now, new aircrafts are made by carbon and Kevlar composites. They start to replace even carbon with Kevlar because Kevlar is more stronger and stiffer than the carbon and more high resistance to the temperature and high corrosion properties. See, aircrafts and general applications are general components which we are using the composite material like gliders, helicopter blades, transmission shafts, ailerons, radars, elevators, flaps, spoilers, engine cowlings, rocket boosters, nacelles, antenna cover, fin, fuselages, portions. These are the some of the components which are made by composites in aircraft and military applications. And in space applications also, many different types of composite materials are used in space application based on the like requirement. Either they can use metal metals composites or ceramics metal composite or polymer metal composite. Sometimes for the body they will use polymer composites. For some temperature oriented component they will made by ceramics matrix composites. See, this is the satellite component. See, some of the components are made by carbon fiber with epoxy, carbon fiber with aluminum skins, carbon fiber with epoxy, carbon fiber with PE, polyethylene, carbon fiber with PEEK, polyethylene ethylene ethers. Even in the electrical and electronic applications like PCB, printed circuit boards and castings of electronic equipments are mostly made by fiber reinforced composite, that too with the glass fiber reinforced components. The glass fiber reinforced composites are transparent to electromagnetic and sonar signal. That means many electrical and electronic components are made by glass fiber reinforced polymer composite. And some of the applications of composites in electrical sector like AC, motor, starter, transformer, fuse blocks, cable ducts, switch actuators, electrical separators, activator cases, low high tension insulators, printed circuit boards (PCB) are the most commonly used composite application in electrical application. Sonar and laser, like radomes and radio and transistor housing. See, these radomes are made by composite material, cable ducts. And in marine applications most popular in boat hulls. And why, like usually they will use glass fiber reinforced composites to make a boat hulls because it's a maintenance free and easy to repair because all glass fiber reinforced or carbon fiber reinforced composite, we can easily repair the components. And nowadays they start to use other fibers also like Kevlar 49 for making boat hulls, decks, bulkheads, frames, masts and space, and even carbon fiber reinforced composites are using for racing boats, making racing boats. And these are some of the applications in marine. Some of the composite application in the marine sector.